This is Chapter 5A Assignment Video. Problem number 1 is asking us to calculate probabilities of the standard normal z distribution, given that the mean is 0 and the standard deviation is 1. So anytime we are talking about a standard normal distribution, this is always the case. The mean is always 0, and each standard deviation that we go up is equivalent to 1, or if we go down, we're going down 1. So we're wanting to know in this problem, what's the probability that a z-score would be greater than 1.27? So 1.27 is about right here, and so we're looking at this area here over to the right. Now, if you are working in the homework, you may click on Help, and it's going to show you how you can also do this using a chart. I'm going to show you that, but then we're going to work on, we're going to focus on how to do it in StatCrunch. But let's look at the chart. So we're looking at the probability that a z-score would be greater than 1.27. This is the table that you can get when you're working on the homework. And we simply, here's z-scores. Here's the first part of the z-score, and then the rest of the z-score goes across the top. So the problem was 1.27. So what we do is we go down to 1.27, so we go over to the 0.07, and that's this number right here, 0.8980. I know that's pretty tiny, but that's the that's the area to the left of 1.27. So what you need to remember is that when you're using the tables, the numbers here in the center are all the areas, and they're always to the left. So in the problem we're working, we need the one to the right because this is greater than. So we can still look up the 1.27 in the table, but it's going to give us this area over here to the left from the table. So the table gives us, it was 0.8980 is the area here to the left. But since we want this area to the right, we're going to have to do 1 minus 0.8980 to get this area over here to the right. So let's do that. If we do 1 minus 0.8980, we get 0.102. So that is how you would do this problem here using the tables. For the rest of this video, I'm going to show you how to do it in StatCrunch. StatCrunch will go to the left or the right, where your tables only give you values to the left. So let's look at StatCrunch. We're working with the standard normal z distribution, so that's stat calculator, and we're going to the normal calculator because this is for the standard normal distribution. Since it's standard normal, we leave the mean as 0 and the standard deviation is 1, and we simply enter the z-score. So greater than 1.27, and hitting compute, we get the 0.102, which is what we got doing it by hand. So the answer is the probability that a z-score would be greater than 1.27 is about 0.102. Let's look at the next one. So this is what's the probability that a z-score would be less than positive 2.01? So 2.01 is about right here, and so we're looking, we need this area that's less than that. So we need the area of all this part here that's shaded. So we could use the table, but I'm just going to go to StatCrunch. So we're just simply going to, this stays 0 and this stays 1. We always leave that if we're talking about the standard normal distribution of z-scores. So I just need to change this to less than, and this becomes 2.01, and we compute getting 0.978. 0.978. So watch the homework on how many decimal places to enter your answer. The next problem is a between problem. So we have, we're looking for the area between negative 0.07, which is about right here, and positive 1.82, which is about right here. And so it's just all the space here in the middle, in the between. So StatCrunch can do that as well. We just hit the between. Now your charts, you have to remember the charts only give you the area to the left, so you would have to get the area to the left of here, and then subtract out the little tail. So, but let's leave it at between. And let's StatCrunch do this. So we have negative 0.17, and our upper number was 1.82, and hitting compute, that's giving us that area in the middle. So that is 0.533. So remember, what this is telling us is if we have some sort of data and we can convert the data to a z-score, and we get our z-score, we can figure out, this is telling us the probability that that z-score for a particular piece of data, that it's going to fall in this range. We know that it's about a 53% chance that it would be in this range here somewhere. Now let's look at the next problem. This is a problem where we are told that the monthly utility bills in a city are normally distributed with a mean of 100 and a standard deviation of 15. Find the probability that a randomly selected utility bill is between 90 and 120. So for this problem, we're going to take our values of 90 and 120 and convert those to z-scores. And then if we have the z-score, we can go to our normal calculator and figure out these probabilities. So what we're looking for is that what's the probability that if we randomly selected somebody's utility bill, and we ask them, we get their utility bill, and we say, hey, what's your utility bill costing you a month? We can figure out what the probability is that would be between $90 and $120, because we know that the monthly bills in the city, they're normally distributed. So we know how they are shaped. They follow this normal distribution. We also know what the mean is, and we know what the standard deviation is. So that tells us a lot. So what we're going to do is we're trying to find the probability that a randomly selected utility bill is going to be between $90 and $120. So we're just going to convert this 90 over to a z-score, and we'll convert the 120 to a z-score and do our calculations based on the standard normal distribution of z-scores. So for the 90, the z-score for 90 is going to be equal to your data score of 90 minus the mean of 100, and that's always going to be given, divided by the standard deviation, which was 15, and that was given here in the problem. So that gives us a z-score of negative 0.67. Now, it's always important that we subtract in the right order here so that we get the right sign here for our z-score. So the order does matter here. Let's do the same. Let's get the z-score for $120. So 120 minus the mean of 100 divided by the standard deviation of 15. So that gives us a z-score of 1.33. So what that tells us is that if your utility bill is $120, that's about 1.3 standard deviations above the average. However, if your utility bill is around $90, you're below average. You're about 0.67 standard deviations below average. So let's look at this. We have this normal distribution of the utility bills. So we're told the mean is 100, and we're down here below average, and we're up here above average. And so we're looking at this area in the middle here. If we can find this area, then we can find the probability that a utility bill would be between $90 and $120. So we're going to convert those to z-scores, and when we convert to a z-score, the average is 0. The mean is 0, and the standard deviation is 1. So now we're down here at negative 0.67, which we'll say is about right here, negative 0.67, and we're up at about 1.33. So we need to find the area in between. Let's go to our normal calculator. This is a standard normal calculator. I'm going to leave, since we're working with z-scores and not actual numbers, we're just working with the z-scores, we leave the mean of 0, and the standard deviation is 1. So we're just going to, we had what, negative 0.67 was the z-score for the $90 utility bill, and 1.33 is the z-score for the $120 utility bill. So that looks to be about this area in red. The area, or the amount that's shaded here of the total, is about 66%. So we know that if we randomly go out and we ask somebody, hey, what is your utility bill a month? there's about a 66% chance that it's going to be somewhere between $90 and $120 based on this right here. So filling this out, the probability of the utility bill is between $90 and $120 is the same as a z-score being between negative 0.67 and positive 1.33. So we went to our standard normal calculator and calculated this area, and we got 0.6. We'll just round it to 2 decimal places this time. So 0.66, which is 66%. So what we would say here, where I have sentence, is like, what does that mean? What it means is that the probability of randomly selecting a utility bill between $90 and $120, $90 and $120, $120 is about 66%. Or you could say 0.66. The next problem is about working out on a stair climber. It says the amount of time per workout an athlete uses a stair climber, those times are normally distributed with a mean of 22 minutes and a standard deviation of 5 minutes. Find the probability that a randomly selected athlete uses a stair climber for more than 30 minutes. So let's draw out our normal model. We are told that the average time that an athlete works out is 22 minutes, and the standard deviation is 5. So, and we're asked about what's the probability that a randomly selected stair athlete uses a stair climber for more than 30 minutes. So we're up here at 30 minutes, and it says more than, so it's greater than. So if we can find the area of this little piece here, then we can figure out the probability that an athlete would use the stair climber for more than 30 minutes. So this time, we are not going to take the intermediate step that we did before, where we took the X values or our actual data values given and convert them to z-scores first. StatCrunch will let us just go straight into StatCrunch and just use the mean that's given. So we were told that the mean is 22 and the standard deviation is 5. So what we can do is jump over here, put in the mean, and then, 22, and put in the standard deviation of 5. And StatCrunch actually behind the scenes converts all this to z-scores for us. So that's what's really happening. Now I don't need the between, I need to switch over to standard. And we're talking about more than 30 minutes. So this needs to be greater than 30 minutes. What do we get? We're hitting compute. We've got this little red tail, so that's the area underneath this whole curve. The percent that's shaded is about 5%. So we know then if this is 5% of the area under the curve, we know that that translates to a 5% probability that somebody would spend more than 30 minutes on the treadmill. So going back to our problem, let's say the probability that an athlete would spend more than 30 minutes on the treadmill is equal to 5%. So I can write that out in words. We'll say the probability that an athlete spends more than 30 minutes on the stair climber, abbreviate here, on the stair climber, is 5%. All right, moving on. The next question is talking about tires, and it's telling us that a lifetime of a certain type of tire in thousands of miles is normally distributed with a mean of 38 and a standard deviation of 4.5. What's the probability that a randomly chosen tire has a lifetime less than 46,000 miles? So, and it's important to mention that this only works with data that we know to be normally distributed. So in all these problems, we're told the data is normally distributed. The data is normally distributed. So because of that, we can apply what we know about the normal distribution, but that has to happen first. Okay, so we know that it's normally distributed, and the mean is 38 with a standard deviation of 4.5. And the problem is asking about what's the probability that the randomly chosen tire has a lifetime less than 46,000 miles. So 46,000 is way up here. It's above average, but we're asked about the probability that it's less than that. So it's probably a pretty good chance, right? Because we know that the average is 38, and we're up here above average, so it's going to be more than 50% because we've got all this part shaded here. So let's just let StatCrunch do the work for us. So we need to put in the proper mean. So the mean was 38. It's actually in thousands of miles, so 38,000 miles. Standard deviation of 4.5 thousand miles. And we're talking about less than the 46,000 miles, but we're just going to put 46 and compute. So that's a pretty good chance. It's about a 96% chance that the tire is going to get their 46,000 miles or less. So writing out our probability statement, the probability that X stands for a randomly selected tire, is going to get mileage, oops, no, not greater than, sorry, the problem said less than 46,000 miles. And we got 0.96 or 96%. So writing this out in words, we would say the probability, abbreviating here, that a randomly selected tire, I'm abbreviating a little bit, gets 46,000 miles or less is 96%. Oops. All right, one more problem for this video. All right, so this problem is about shopping. And so it says a survey indicates that for each trip to a supermarket, a shopper spends on average of 38 minutes, so there's our mean, with a standard deviation of 10 minutes in the store. There's our standard deviation. So the lengths of time spent in stores are normally distributed, that's good, and are represented by the variable X. So a shopper enters the store. Find the probability that that shopper will be in the store somewhere between 30 and 40 minutes. And then the next part of the question asks, when 200 shoppers enter the store, how many shoppers would you expect to be in the store? So let's look at the first part of the question. It says, find the probability the shopper will be in the store between 30 and 40 minutes. So this is a between problem. So actually, this should be the probability, and we would write it this way, that it would be between 30 and 40 minutes, X standing for a shopper, and we're trying to figure out what is that probability. So we're told that the average is 38 minutes, and the standard deviation is 10. And we are asked about a between problem, so between 30 and 40. So 30 is going to be down here somewhere, 40 is going to be up here above average somewhere, and we're needing this area. So if we can find this area in between these two values, that corresponds to the probability. So we're keeping this in between, and be sure to change your mean. Actually, mean is 38. In this problem, the standard deviation was 10, and we're looking at being between 30 minutes and 40 minutes, and we get 0.37, just rounding there to 2 decimal places. So 0.37. So the next part of the question says, when 200 shoppers enter the store, how many shoppers would you expect to be in the store? And I probably should have added, how many shoppers would you expect to be in the store between 30 and 40 minutes? So let's add that here, between 30 and 40 minutes. So the first part of the question asked, what's the probability? Now this part is asking how many. So we know that it's a 37% probability. So we would consider that if there's 200 shoppers in the store, and we want to know how many of those are going to be there between 30 and 40 minutes, that's going to be this calculation here. We would do the 200 shoppers times 37%, 0.37. And if you do that, that's about 74 shoppers. So to answer the question, we would say, there's really two parts to this question. We would say the probability that a shopper, this is a shopper, just one shopper, that a shopper will be in the store, between 30 and 40 minutes is 37%. If 200 shoppers enter the store, about 74 will be in the store between 30 and 40 minutes.